Hello everyone, I am presenting our project titled the AI-based multi-class ensemble learning system for cervical cancer detection developed as a part of our final year project. In this presentation, I will briefly cover the introduction, problem statement, methodology, model design, results, conclusion, and future work. Introduction. Cervical cancer is a major health concern for women. Manual screening of cervical cell images is slow and prone to human error. So AI-based automation can help in faster and more accurate detections. Statement of the problem. Early detection of cervical cancer is challenging using manual methods. Our objective is to develop an AI system that classifies the cervical images into normal, precancer, and cancerous category. Scope of the project. This project uses the Medley LBC dataset and an ensemble of deep learning models. A Flask web application is developed to provide real-time prediction. The system includes dataset training, ensemble modeling, and a web deployment. It does not include real-time hospital integration or clinical diagnosis. The dataset is reorganized into three classes: in cancer samples and high computational requirements or key limitations. Methodology. Our methodology includes data pre-processing, model training, ensemble learning, and web integration using Flask. We use efficient net BO and MobileNet V2 for feature extraction and combine them using soft routing to improve accuracy. This diagram shows the complete workflow from dataset input to predicting output through the web application. Use case diagram. This user uploads an image, the AI system processes it, and the result is displayed to the user. The class diagram represents the interaction between the image input deep learning models and the ensemble classifier. The sequence diagrams explains the step-by-step interaction between the user, model, and the web interface. Algorithm Efficient Net BO. Efficient Net BO is a lightweight CNN used for feature extraction and achieved 63% accuracy on our dataset. MobileNet V2. MobileNet V2 achieved 96% accuracy after some fine-tuning. By comparing both the models using soft routing, we achieved a stable accuracy of 95% across all over classes in Ensemble model. Hardware and software selections. We used Python, TensorFlow, Flask, and GPU-enabled system for training and deployment. Implementation. Both models are trained separately and implemented into a Flask web application for real-time prediction. These are the important code segment. This coding part represents the creation of three-class dataset, and we split the dataset into training, testing, and validation. This coding part explains the data pre-processing and augmentation. This is the coding part of the efficient net BO model creation. It uses activation function as softmax and the optimizer add loss categorical cross entropy. This is the coding part of MobileNet V2 model creation. It uses optimizer add loss categorical cross entropy and the activation function as a softmax. This coding part explains the combined ensemble model with the help of the soft routing. Now I'm going to demonstrate my project. Here I created one folder like cervical web app. In this collab file, I upload my project IPYNB file, and under the models, I upload my ensemble model in Keras format. I created static for visualizing, and here's the code for templates, index.html and result.html. Here I create an activate environment. And these are the codes for my app.py, and this is my Docker file. And here's the requirements.txt. Here we used a Flask 3.00 and Unicorn 21.20 and TensorFlow 2.10 model and NumPy 1.23.5 and Report Lab, which is used for PDF creation in website. So these are the requirement.txt files. Now we first activate the environment using the command, like because I created the environment days at a V environment, so I activate it with the command. Next, I run it using the command python app.py. It load the model. So we have to follow link. We have to follow any link. This is the page we achieved after following that link. So I'm going to fill the patient detail. I put give a date of birth. And the age and today's date and number. And I'm going to upload image. I'm predicting. So the result it was given like a normal. It also provide the percentage values and it will be give the user information. So we can download it as a PDF and we can predict another by clicking predict another. It will be came to this page. This is the user report downloaded. So it will be given like this. So this was this project. This is the home page of our web application where user can enter patient details. User uploads cervical cell images through these interfaces. The system displays the predicted class along with the probability scores. A downloadable PDF report is generated for future medical references. This is a test case part. All functional test cases such as image upload, prediction, and report generation are passed successfully. These are the result part. This is the Ensemble model confusion matrix. In this, in normal classes, about 92 images out of 93 are correctly classified. In precancerous, about 40 out of 42 images is classified correctly into precancerous, and about 8 out of 12 images are correctly classified in cancerous category. This is the classification report. You can at least see the accuracy is achieved 95% and it works well with the stability across all the classes. Conclusions. Our AI model, AI-based ensemble system provide accurate and reliable cervical cancer classification and support early screening. In the future work, we plan to include expert feedback, advanced models, and mobile or cloud deployment. References, these are the references we used for our project. If you have any questions, you can comment below. And thank you for your time and attention. Thank you.